Welcome, this is where nerds come to learn things. If it's your first time here, click on the subscribe button and on the bell icon to get notifications about new videos. Thanks for watching, hope you enjoy it. Let's see what's in the box. Right, so this is a new lens for my camera, and I'm going to zoom in. Zoom. And hopefully autofocus. Come on. Okay, this just fixes focusing. This is why I got a new lens. So this is a EFS 10 to 18mm, so it's a wide angle lens. It's supposed to be macro as well, 0.22 meters. We have image stabilisation and autofocus stuff. So this is basically like the lens I've already got, except it's a wider angle. It's a bit dirty, so someone's had their fingers on it. It's okay, I guess I can sort that out. Is that the same size cap? No, it's not as big a cap. That's okay, but that's alright. 67mm, so that's what I thought. And specs, as you can see on the front there, 1 to 4.5 to 5.6. So look at the other end. Let's all clean that in, so that's alright. So I might chuck this on and maybe do a comparison. Zoom back out. Zoom. Now unzoom. Unzoom. So there's the current widest angle I can do on this camera. Let's change the lens and see what happens. Okay, and here's the new lens. I haven't cleaned it yet, but you know, you get the idea. And that's the widest angle the new lens can do, and there's the monitor. How's that for a wide angle view? That's pretty cool. Zoom in, and that's fully in. So that should actually be very similar to the widest angle I could do on the other lens. This is my normal lens that I use. So macro is 0.25 meters. This lens on the 18 to 55mm. This lens that came with my camera, which is known as a kit lens or something. Apparently, I don't know, I'm not really overly into that stuff. So we'll see if this lens actually does it. What I'm hoping for is that the wide angle of this lens means that I can actually mount it lower down, where I can see the camera again, not operate the controls properly, and still be able to get the focusing nicely. That's what I'm aiming for. I might give it a go, actually, just bring it down and see how it looks for the rest of the video. Right, so I've got the other lens on. I've lowered the camera down. So this is back down to kind of where I used to have it before. So it's about 20 centimeters lower, and I've reduced the apertures down to 9. We'll see if it still works okay for focusing. So this is, I had a thread on the EV blog forums asking for tips. Actually, I was actually asking about replacement camera suggestions and stuff like that. But ended up talking about basically how to use this one better. So trying a few different things out. Going higher was one of them. A wider angle lens was also another option. So this is what I've gone for now, is a wide angle lens. So these are LCD displays. Supposed to be serial controllable, SCO, SDA, VCC, ground, 4 pins, and there's 2 more pins over here for something. I don't know what they're for, but they're for something. Might be, I think it might be backlight or something. Is it? Yeah, smart LED on there. That's not bad. Actually, it's about sort of halfway up. From what I can see on the monitor, that's about halfway up. Right, that's focused there just. So I've got this range. That's not bad. That's like half the distance, which is kind of what I was aiming for. So yeah, this is I think it's a blue one. So you got the serial to parallel adapters on them, basically pre-built in. I've got no idea about using these yet. I will have to figure out how compatible they are. I believe there are libraries for them and stuff like that, but it might just be using a standard Hitachi base anyway. There's also a chip on there. PCF8574T. Is that a PIC? Is it? I don't know. I'm not into PICs. That's my guess. All I'll be doing is conversion to the Hitachi format for those parallel display. Just like the Arduino, like the SparkFun serial display module, it just does an Arduino to convert instead. So hopefully it's got the same command set. I guess I'll find out when we go to use one. So I've got, was it 5 of those? 4 of those? 5. Yeah, I should be able to count, shouldn't I? I'm old enough to count now. Yeah. Right, next thing. Let's see what's in here. It's from Malaysia. Sorry, Thailand. Not sure what it is. They seem to have like the whole bit of string around it thing, which is interesting. Yes, I'm pretty sure that's where I've got to open it, just there. Little crocodile clip banana plug thing. 220 volt, wrong plug, but no well. 220 volts, what I asked for anyway. Nice of them to leave a little message on there for me. So it's got X and Y on here, which may give things away a little bit. That's like a label stuck on the back of the box there, I can feel it. That's alright. Both go to an oscilloscope. Curve Tracer Adaptor. So these are little kit things someone's selling online. I should actually have a look inside actually. Oh dear, this is, you can use it for testing components. So you hook up the probes to a part and in theory, test the response to whatever those are. I don't know, I'm going to have to figure out how to use it. No manual, so I'm going to have to just figure it out. It looks nice enough, constructed nicely. These are on eBay, there's lots of these on eBay, probably from the same person. Looks like it's building these as kit. Just open up and have a look inside, eh? See what it actually is. I'm guessing it's just going to be these two screws here. No, these are threaded, proper machine screws, so there must be inserts in the case, which means it's probably a good quality case. There we go. Right, oh, it's got like a preset in there. Interesting. Really, is that all it is? Wow, there's not much to this, is there? I was expecting more. I really was. Okay. So it's got a multi-tap transformer, which is only using up to 220 volts. Going through the switch, which is switching something. You have to guess which one it's actually switching. I suppose I have to look at the wiring net, make it safe for New Zealand. We've got an NM317 voltage regulator down here. That's obviously the voltage adjustment just there. Okay, so that's what it's doing, is using that to adjust the voltage. So you're using a preset pot. Interesting. And then obviously goes to run to that positive tab, which also goes to the X. So it's going, hold on, let's trace this through, shall we? That's AC. So the transformer output going through this resistor array here onto the back of the switch, so you're obviously choosing this through the resistors to set that current, theoretically. Which also goes over to the ground over here, which has got a 0 ohm resistor linking the two B and C's together, which is okay, I suppose. So that's setting the current through the ground, and the positive has got this bridge. It goes through. Negative comes through here, well, so the positive AC comes through here, phase we call it, I suppose. Got a bridge rectifier. That's an interesting setup. So it's running on AC. I'm trying to understand what it's got this bridge rectifier here doing. That side would normally be the AC, the AC across those two sections there, or across those two there. So we DC out. This is an interesting setup. But it's got a voltage regulator here, so it must be some DC. But there's no smoothing, no capacitors in it. I think this is going to require some further experimentation. I'm going to have to hook this up and actually see how it works. It's positive going through that way, negative going through that way. So yes, that's the negative. 0 volt rail will be that one, well, rail if you can call it that. Which goes to that diode, but it can't go through that way. So it only goes as far as that. Positive can only go through this way, so that's definitely positive going to that side of the regulator. So then it's got the negative going there. The positive doesn't go anywhere, it only goes to this pot. What's the pin out for one of these things? This doesn't make a lot of sense. Right, so drawn out a circuit diagram here. I was going to actually just measure these resistors and just see what values they are. We'll add that to it, and I'll show you what I've come up with. It doesn't make a lot of sense, this circuit. I don't know, it's a bit weird. Anyway, 10k, 1k, 100 ohms. Okay, so 10, 1, 100. And there's also that variable resistor here. What's that set to? 141 ohms, roughly. Now the interesting thing with this, so here's the circuit. Let's excuse, oh, I need to, no. You have to have the Defpom, right? Dave's got a lot to answer for. So this is the circuit. It's like, well, you've got the AC coming in. You've got a tap off point here to one of those points. Which one was that? That was that one there. That's the Y. That's the Y. Put it on there. So that's Y, and that'll be X. So it taps off, goes to the Y. Okay. And then goes to resistors, obviously to limit current and voltage, which then goes to the negative on that terminal, which also then goes to the shields and those, right? So it's referenced to that, right? So it kind of references together. It would have been actually nice to see an earthed lead, a 3-pin lead coming in with an earth, which then references it to earth properly. But I suppose in a way this is floating, which might be a good thing too. So then we got the positive side, I suppose you could call it positive side. I mean, it's an AC waveform. We've got this diode rectifier system here. Well, it's like a bridge rectifier, but it's not like a bridge rectifier. It's odd. I mean, you got the standard traditional diode directions like that, but these ones are back to back, which is a bit strange, right? So on a positive waveform, we'll go through there, it'll go to that leg, which then goes to the output pin of the NLM317, not the input pin. Okay, and on negative waveform, we go this way, which go over here to the input pin via the adjust pins. It actually goes to the adjust pin and then to the input pin. Again, odd. Why is it going to the adjust pin first, not the input? That's weird. And but if it's going negative, it can't get anything through this way. If it's going positive, it can't get anything through that way. This can only be getting a feedback from this one here, but that can't work. I don't understand how this thing works. Is it complete bullshit? I don't know. I'm going to have to power it up and find out, aren't I? But it doesn't make sense to me. Is it relying on the breakdown voltage of these diodes in order to limit the voltage available? Is that what it's doing? I don't know. It's odd. So let's hook it up to a scope and power it up and chuck a part on it and see what happens. So there you go. I've got the curve tracer set up. Well, a tracer adapter, as they call it. I've just got a Zener diode in there, 4.7 volt Zener, and that's what I'm displaying on the trace there. So I can actually change this limit there, which makes it a bit smaller. I can change the current, I can increase that, current / voltage, whatever the hell it actually means, and it does change it. How to read that, I'm not sure yet. I'll have to figure that part out. So let's take the diode off. Let's stick a capacitor on. This is a 1UF capacitor, and that's changed. It's basically 2 lines. If I change the scaling a little bit on this, so there you go, it's forming a circle-ish thing. If I put limiting on there, it does a little bit differently. And if I change these currents and things, it changes it again. So it is doing something. Is it right? I don't have a clue. Yes, it does an XY trace. I suppose it's doing what it's meant to do, but it's not really a curve tracer, is it? I don't know. It's just an XY plotter. So, I mean, yeah, you can use it for testing stuff, I suppose. It's not the easiest thing to use, though. Let's check the diode back in again in that setting. So that's what you get in that position. So maybe it's a case of just finding the right settings as well. I mean, that's that. So 50 volts to division, 20 volts to division. Mind you, I'm using a direct BNC, so this is set 10 times as well. So it's actually not right. So it's actually going to be 1 times because I'm using a BNC connector with BNC cable straight in. That's on channel 2. Channel 1 is probably the same deal. It's on 10 times as well, so make that 1 times 2, or 1 times as well. That way at least it gives the correct voltage reading. So that's 2 volts and 5 volts. That makes a bit more sense, doesn't it? And I've got bandwidth limiting on there. Let's turn it off. Channel 2 is already off. Impedance 1 ohm. 1 mega ohm, sorry. I've got AC coupling, obviously. If I go DC coupling, what happens? Now we get what looks more like a curve trace. Okay, that looks more like a traditional curve tracing. I'm using DC coupling instead of AC coupling. Okay, so let's try the capacitor again. Maybe I should be using DC coupling, not AC coupling, in order to see that curve tracing. Put this Zener back in again. Sorry about backwards and forwards. I'll probably have to edit this down or something. That's pretty measurable, isn't it? Which one's which? That's the height on the width. There must be a way of measuring this. So it's 1 volt division horizontally. Is that right? Yeah, so it's 1, 2, 3, 4. Now that is working. So I've actually measured it based on divisions. So line it up to that division there. So that is 1, 2, 3, 4 divisions, and it comes down over here, right? So that's a 4.7 volt Zener. So that is actually looking like it's kind of the right thing. If I change the current now, that is on 100 microamp, apparently. The 10 milliamps, it changes it quite a bit though. So I don't know how reliable that is. For the bypass, does that change anything? Slightly. makes it a bit harsher, but that makes it like 5.7 rather than, I don't know, if the currents aren't right, I suppose it could be wrong, couldn't it? Maybe there's a calibration I can do on that to make sure it matches. I don't know, I've got it on my Variac. Let's put the Variac voltage up. Does that change anything? It does. I'm dropping the voltage down, you watch that curve. See that curve there? It's changing as I'm changing the supply voltage. So it is changing. If I go up to 240 volt, which is what the main supply here should be, I've got it on the Variac because it's supposed to be 220 volt transformer, you see. Yeah, I don't know. So it's like it's got diode. This switch is bypassing those diodes as per this diagram here. Try drew out for it. If anyone wants to make one, there you go. That's how to make one. It's odd, but yeah. I can't remember how much I paid for this now. It wasn't that expensive. I think it's about $50 or something like that. This is, you know, nice little thing to play around with. You could use it for testing parts, I suppose. It does tell you. So it is doing what it promised, I suppose. For making both the same voltage levels, does that make it different? Would that give you a more accurate display for what it should be? I don't know, maybe. I bet if I change value, it'll change it to 4.7 cap instead, eh? I should change that shape. There you go, it's narrower. So, I suppose that's what you expect, isn't it? Yeah, diagonal line is what you expect from a resistor. Yep. It's typical XY plotting. 4.7 microhenry inductor. See what this does. Straight up and down line. Okay. I was expecting something different from that. I don't know, I could be wrong. No, I don't know. It's doing XY plotting. I mean, my old Dick Smith 60 MHz analog oscilloscope had a component test point on it. That's basically what this thing here is doing. This is providing a power supply to do that component testing. These results I'm getting here now are exactly the same thing I had years ago when I played around with that component testing thing on the Dick Smith unit. Yes, I remember now. Let's get a different diode. Right, so here's a standard silicon diode. One in 4148. There you go. That's the response you get from one of them, as you'd expect. Yeah, it works. I think if I go back to AC coupling again, that gives me some interesting details, doesn't it? Put them both on AC, then you also get the waveforms. You actually see a phase difference there too. I don't know, could that be good? It's probably a way of checking that out as well. Might have some use. But okay, it's pretty cool. Alright, I like it. I think I'll call that a success. When I first opened it, I thought, well, there's not much in here. I've been ripped off because it's not really what I was expecting. I was expecting to be some electronics in there to go with it, you know. But no, it does what I expected it to do. A manual would have been nice to tell you how to use it. Let's try and just figure out what the hell's going on here. Now, this is a negative, so I'll just probe it on there. So we got what we got on here. Let's mark these voltages down, shall we? 4.51 volts or 4.49 volts on the adjust pin. Input pin 4.57. And the output 5.3. I don't know, make of that what you will. What the hell is that thing doing? I really don't know. So that's the output pin, which should go into the... That's the diodes, it can't go anywhere. It must be using those as a bridge or somehow. I don't know, it's odd, I don't understand it. I understand all sorts of stuff. I don't get how this is working. Anyway, I don't know. Maybe it's breakdown voltage in the diodes. Right, let's see what's in here. Canon RC6. Awesome. This is supposed to be the remote control for this camera I'm using right now, which will allow me to push record without having to touch the camera, which would be great because right now I have to, every time I touch it, the camera shakes around and I have to edit that piece out. And I have to delay when I first start recording. I have to push the button, wait for the camera to stop shaking, and then start talking. So, not having that problem would be nice. Now, this is purchased from an official camera supplier, so I paid more than I should have done for this. I wanted it sooner rather than later. I think I paid like $30 in New Zealand for it, but you can get these things, if you're willing to wait, for about $2 or $3 from places like AliExpress and Banggood, places like that. They can get these easy enough. Yeah, the battery in there. CRT032, as you would expect, quite common. Let's push the button if it stops. No. No. Let's read the manual. Taking pictures. Set the camera drive mode to remote control shooting. Okay. I guess I have to set the camera up to use it. Right, I have to look at. I can do that then.